I'm Jonathan. Nice to see everybody here. Is everyone having a good time at Join? Yeah? Okay. We'll do a cheer at the end all together, okay? Good. So, like I said, this really is preparing tidy data sets, for data science workflows. And one of the big things that we've seen, or we've all heard this statistic, is that 80% of a data scientist's time is spent preparing data. And to my colleague last year, I like to reuse this one. The other 20% we all know, right, is spent complaining about that 80%. So thank you, Russ, for that one. No, so what this comes down to, and the reason why this is so important is that actually, right, the quality of the data that we use and the cleaning techniques that we decide to use in prototype equal how good, and to some degree, right, correlate directly with how good the model quality is going to be. So everyone comes up like, okay, we want to not have to clean data anymore, and I'm going to be the first person to be like, look, we got to do it, but can we do it one time, or can we do it in a fashion that allows us to scale this work to other parts of our organization, other team members, and let's do it in a way so we only have to do it once, right? Let's not have to kind of keep these siloed spaces around. So this whole idea of Looker being the single source of truth will continue to surface here. So this is a data science workflow. And it's very simple, as you can all see. It's actually fairly complex. And this chart actually starts from whether or not the actual thing we're going to be modeling, right, this question that we have, is even viable for the business. And it walks all the way through to the end of, okay, we're going to surface predictions, and then what do we do with those predictions? Are we putting in a production environment? So on and so forth. And for today, what we're really going to be focusing on is this one piece. And in data science, I'm going to change kind of the lexicon here between a couple things, is that this is the EDA, part of the EDA, the exploratory data analysis piece, where we actually look at the data, we see where there's holes, we see where there's bad values, and we always keep in mind what the data should actually look like. And so this first diamond that we enter into, do you have the data? And this problem is actually solved sometimes by selecting a small set of features, and features being, once again, just another name for columns dimensions. And these are going to be the fields we use to actually train our model. So if we have it, it's great. We're going to go kind of more that route today. If we don't, it's really about the ETL. And so this problem is actually a balance between the ETL and the EDA. And depending upon the resources you have available, the type of modeling, is this a prototype, is this going to be production, right? All of this will translate into whether or not we want to move through these iteration cycles in kind of more on one side of this or on the other side, and then potentially bringing these definitions that we make, or these cleaning techniques, back down to canonical definitions that we use. Cool. Okay, so up top, I'm going to demo now. I don't know if I need to flag you guys or something. Like that. Boom. Cool. Okay, so we're going to go kind of quickly through this. I'm obviously not going to be able to describe every single cleaning technique that's out there. I'm going to try to keep it to simple examples and talk through a couple of the strategies that we've built out and really where we see this vision going. I am never going to take Python or R away from you, I promise, okay? That is my promise to you. I only want to provide another tool, and that's our goal, is to provide another tool in your tool belt as scientists, as analysts, to be able to do this. This, and what we're looking at here, is just a bike data set. It's the Seattle bike share. A lot of ride shares are solving this problem. The bird scooters, right, are trying to solve for this problem right now. I don't know if you've tried those out, or if they're just, of course, littered all on the sidewalks, and then we're writing in our complaints, or whatever it is. The point is here is that the goal is we're predicting the actual trip counts that day. And these are the stations around Seattle that we want to be able to optimize for how we actually come up with a monetization strategy that then maps to promoting bikes, distributed bikes across each of these stations from our customers, okay, or from our riders. And so the first thing we do, and really where I'm going to spend a bulk of this, and I'm actually going to zoom in here because I think, is that a little, yeah, great, that's really easy to see, cool. Okay, so the first piece here, and this is really important, is what we've built out here is actually a dashboard that this first tile is a metadata layer of our entire, at Looker, our entire ecosystem of data. So this is really important. Number one, I'm going to give a shout out to our data engineer, so this is on the ETL side, of providing basically the scope of all the data that we could possibly choose from. In a lot of databases, you can actually look at the metadata tables. You can model them in Looker. It becomes great because now we can know exactly what's there. I can get alerts about new tables or new information that's coming in. Obviously, there's some fields to clean that I still need to go through over here, right? But what we're looking at is we've got everything from the tables, the data sets we're working with, how many bytes these tables are, the rows, the columns themselves, the data types of these columns. And so traditionally, I have to run I know it's simple commands in Python or R to just kind of start looking at the data. I want to look at the first couple rows. I want to look at how many nulls there are, so on and so forth. Now, as we move through this dashboard, there's going to be a couple pieces we're going to flip back and forth between. And so this table, I'm going to zoom out so we can get back to the dashboard, really gives us that scope that we want to be able to choose from. Here's all the data I might choose. Now, I've only surfaced some public data here, so it's safe. But we will be looking at the bike share data from the actual application or data collection system they have, and then weather data. Okay, so we're modeling weather data. Cool. Nice. So I'm actually going to flip now to Python, okay? And that's right, we can now pip install Looker's API. So you guys, as if you use Python for R, you can still do this Swagger code gen or an SDK, right, to be able to get there, an SDK. For Python, you can now pip install this. You can basically use this as just another library that you'd go through. In this particular example, I'm actually doing something that I find is easier and better to do in Python than I am finding it was to do in Looker. And that was discover kind of null values of certain features that I'm choosing. The reason for that is because I have to write one single measure, one-off measures, calculate nulls, run a bunch of different explorers, filter down to the nulls, count them, and like that just takes a lot of time. For this, what we can do is we can actually basically use a visualization outside to help us understand what type of cleaning we might need to do. So typically, we've got to define a whole bunch of functions, right, or even just calls that basically clean the data. It lives in this siloed Python notebook. If you speak Python or you write Python, great. Maybe you understand my entire branching strategy I've laid out, and you can access this, but it becomes very siloed. Please don't copy my secret. I promise to change it after. Okay, now we're authenticating, and then this is where we actually get to the good stuff. So the first thing I'm doing is I'm instantiating the look API. What I'm going to do is I'm going to call that metadata table, and I build a dictionary of the columns that I want to use. So now what I can do is when I actually want to call all the data, which is laid out in joins, right? In our model, we actually have in Looker, we've got a set of joins for the Explorer that I'm using, and I can access as many data points as I want. It could be transformations that I've built in as well. And I can now just basically, without writing really much SQL at all, be able to now just call the fields that I want out of that particular dictionary. I'm going to come back to this and talk through some of the commented out code here. But really what this does at the end of the day, I get kind of the format. I'm actually having to sample here. So what that means is that when a lot of this starts moving back into Looker, we can actually now look at all of the data because I don't have to sample certain portions of it to just look at, okay, I want to look at the first, let's say 10% of dates, and then I want to see kind of where there's problems, maybe or missing values. And so to show you what that looks like, if I go back, I've produced a visualization. This is in just kind of an open source library that I found. And you can see the bands of where the actual nulls exist. And so this is something where we've got either omitted values, we've got things that we want to build out. We need to maybe even make this categorical variables or dummy variables on top of this. Now, I don't want to have to do this every time. I want to be able to do this one time. So this gives me some transparency into at least the null part. What I am going to do is I'm going to flip back here. I'm going to go one further, and we're going to check out the next layer. So this is now other cleaning techniques, or at least modeling techniques, that help us be able to do this. We can engineer features. In this case, what we've done, which is actually more of a challenge to do in Python, is to take historical weather data So I've got all the history, I've got the actual values that in the past values, along with a forecasting model that we're unioning together and pointing out into the future. So for every future prediction that I'm making, I have a set of weather data that's being forecasted as well. And this now lives as one single object that I can reference throughout other models, throughout really any type of cleaning modeling that I'm going to do in the future. So we set up now also a branching strategy. We also have new endpoints, so I'm going to go back. The new endpoints here are to be able to actually go into dev mode. And traditionally, we haven't been able to do this in Looker, and so this workflow actually becomes relatively difficult. We can now very easily from the API go into dev mode. I can update a Git branch, or I can create a new one, or, oops, oh, there's two here. Or I can create a new branch. And so this now allows me to not only look at one version of the cleaning that I'm going to do, right, but I can have multiple versions that I'm ready to use at any given time because I can call the same fields with different inputs for those values. Why is that also really important? I can have a team of analysts and LookML help me with this cleaning as well. So we're not talking about just scaling the workflow for the individual. The data scientists, we become the master at this instrument, but what we become now is a conductor of an orchestra. And so hopefully what we're able to do now is continue this propagation across teams, across models that we're doing. At any given time, I can now pull any version of these features and any cleaning techniques that I've provided to them. This, in these 3 lines, is actually really big, so I want to just emphasize that very strongly. This is huge to be able to do this, and really, historically, we have not been able to do at Looker. Okay, back to this. So in branch 1, right, this is maybe my master. There's going to be some of this cleaning. Now, maybe we're in the middle of this iteration, right? We've actually built a model. We've actually chose 2 features to use. We chose weather and temperature, okay? And we're looking at kind of how that produces future values of trip counts and how that measures against our scoring metric. So there's other things, though, that we want to start bringing in here and that we may want to set as our kind of branch level 1, right, or our master, as the canonical definitions. And these are going to be things like data types. How many times have I seen a date as a string and just thought to myself, not again, right? This is the stuff that takes, and every time now, when I go write Python, guess what? I have to remember that that's a string and that the error I'm getting is actually coming up because of that. That is a very simple example that I've banged my head against a wall for hours trying to figure out sometimes. So that's huge to be able to do some of this. And these become the canonical definitions. And then what happens is do we decide to bring this back to the ETL at some point? Or is it fine that it lives in the modeling layer? But any time now when we start branching off of this, we have all of those transformations that are set now as our base. Other things, right? We want to actually convert something from, right now it says has rained, and then there's this little rain and a smiley face, and we're like, yay, except for my model hates that. So I need to turn it into a 1 or a 0, right? So we're changing categorical variables into a readable format, making dummies out of them. Some other things to, building your case whens if we've got to change things over. And some of those more advanced techniques of how do we solve for these null values? Are we actually using a different model to then predict these values, right? Do we have some holes that we need to fill? Do we have other massaging techniques? Are we taking the log of something to account for outliers or distribution to normalize it? So what we're also then able to do is we're also then able to start exploring stuff. This is a box plot that I just threw in here. And this is a great, actually, representation of how I've kind of looked at it across the events. So this is where the null values were produced at the bottom. And actually, you can see the NA value here. And what we very quickly see from this, now some of this I know you can do a box plot in Python, right? So you get the choice now of does it make sense to do it there? Or right now for me, it's very quick. I can even choose different types of the dimensions that I want to build this box plot again, as well as the grouping field that I'm comparing this to. And this also means that we see there's a bunch of outliers, right? What this is showing us is there's a bunch of max values that we need to handle. So this is going to skew the model when we go after it. The next is our famous histogram that we all love. And this actually then shows those outliers, right, as they trail off into the future. And so we have to come up with what we're going to do. Is this something where we just drop these? So one version of the code is that we put them in the SQL always where, we cut them out, anything over this value. Let's just never include it in this data set. Let's not worry about it, right? There's a small portion of that in terms of the amount of data that we have. So we still have our statistical significance. Or we can all chop them to, back down. Should we just say any value that's over 1,000 for the trip duration, should we just make it 1,000, and then we'll bring it back more for that? Then maybe we need another technique. If we produce a bimodal distribution, then maybe we do need to pull it actually back into Python at that point and use a different visualization to be able to determine what we're going to do with that cleaning. Okay, we're right on time. Beautiful. So I think the last piece, and really the piece that I kind of want to leave everyone with, is there's really three major components that we went through here, and maybe more. I shouldn't even give a number, but I would say that if you could walk away from today's session, being able to scope how much data we actually have access to and quickly choose what we want is an incredibly powerful tool, right? That alone, not all of us are going to be at a company where they have an entire metadata layer of all their data and how it's all put together and everything. Some of us, maybe we already are working at a company like that, so great, that's awesome. Maybe it's worth investing the time to build that out because now, as I go forward, I very quickly can even choose data sets, see everything, data types, everything along with them, and be able to then select and choose what I want to prototype with. The next is a Git branching strategy, which is really big, right? This piece that I call out of being able to just choose, hey, I want to choose this branch. It's got this version. It dropped these nulls. Oh, I actually want to compare that to one where we've actually maybe taken some of those values in this example, right, and we've just cased them to something else. So I really can iterate through those. I could even train models at different times. I can scale to different analyst teams. So I can also get help from my colleagues to do this. Not that I've worked with some data scientists and no one loves the question more than like, hey, you want to help me with my cleaning? Come on over. This will be great. We'll have fun. No, we want to, most of the time at least, we want to spend tuning all the hyperparameters and actually doing the modeling itself. This workflow then leads in to being able to just state that I'm not going to tell you, like I said, Looker is going to solve all of it. But you can see that if you can build some of this workflows on top of, what ends up happening is that over time, we will have more visualizations to support these workflows. We have science teams that have already brought in their own, that they're bringing in, they're doing whatever it is. If you want to do your PACF and ACF curves and you're doing some forecasting model and you want to see where values cut off, you could bring those in, right? And over time, that will continue to propagate and continue to be a place where you can very quickly even surface the model predictions back to a database and then model them in Looker.